Welcome all of you to Computer Programming with Sherin. Today we will discuss about array sorting. For example, we have selected two types of sorting here, selection sort and bubble sort. We will discuss these two sorting. Sorting means arranging an array element in an order. It may be ascending or descending. So first I will explain the theory concept. We will discuss the selection sort first. So using random 5 numbers, I'm trying to explain this. So randomly I'm just giving some numbers over there. Say 5, 3, 8, 12, and say 2. So randomly I selected 5 numbers over there. We'll provide a border also there. Okay. Now in selection sort, first we will consider the first element as the smallest element. So we are just imagining the first number will be the smallest number. So it's an imagination only. So we are creating a variable over there called SML and saving that value there. And the smallest value position also we have to mark somewhere. So I'm just creating a variable called pos and the position is 0 itself. Other position also we will mark over here. First position 1, 2, 3 and 4. These are the indexes over there. So first 5 index is 0. So that's why pos equal to 0. Now what we have to do? We have to compare the smallest number with others. So this 5 I have to compare with 3, 8 and going on. And if you can find out a smallest number other than this, then this SML value should be replaced with that number and the position also should mark over here. So first we will compare with 5 and 3. So 3 is lesser. So what we have to do? We have to replace this 5 value with 3. So actually we have to remove that value. If you are assigning 3 to SML, of course the 5 value will be removed over there. But for explanation purpose, I'm just keeping that number over there. The previous number I'm keeping over there. Okay. Now the position also will change. 3's position is 1. Now this 3, SML value is 3. 3 should be compared with others. 3 and 8. 3 is the smallest, no change. 3 and 12, no change. 3 and 2. Now 3 is larger than this number. So it should be replaced. So 3 should be replaced with 2. And the position of 2 is 4. That should be applied over here. There is no other number. So the first comparison is okay. Now after this comparing, we have to replace the first element because we are starting with this number, that with position fourth value. Position value is 2. So 5 and 3 should be replaced. So 2 should come here and 5 should go over there like this. And again we will repeat the step, but now we will start from here itself. And if you're taking any number of case, the smallest number will automatically come after this first comparisons. So we can say, simply say this is in sorted order. We can ignore that number and we can start the comparison from the next number itself. So here SML will be equal to 3 and pos value will be equal to 1, right? Then we have to compare small with others. 3 and 8, no change. 3 and 12, no change. 3 and 5, no change. Because we know like 3 is lesser than all these numbers. So we have to replace with smallest number. Which one? The first smallest number, that is 3, with position 1. So 3 should be replaced with 3. So there is no change actually, but we can mark like this. The first two numbers are sorted already. Now we have to repeat the step with next number. So here SML will be 8 itself and position will be 2. Now what you have to do? 8 should be compared with others. 8 and 12, there is no change. 8 and 5, 5 is smaller. So we have to replace 8 with 5 and position also will change from 2 to 4. Now we have to replace this 8 with fourth position number, that is 5. So 8 and 5 should be replaced over there. So here 5 should come, here 8 should come. Now we can say this much will be sorted. Now again we have to repeat the steps. Smallest is now 12 and its position is, smallest is 12 and its position value is 3. Now what we'll do? 12 should compare with the next number, 12 and 8. So 8 is smallest. So we should replace 12 and 8. So here 8 we have to mark and the position is now 4. So 12 and 8 should be replaced. So copying it again. So here it will come 8 and this is 12. And we can say this is also sorted. So first 4 numbers are already sorted. Now we can say we don't need to sort the last number because it will be already sorted. Now check again. We can say 4 sections are there. 1, 2, 3, 4. The final section is like already sorted one. So these are the one. So I'll just give some red color over there. Now in first time, this is comparing with 5 and 3. 1, 2, 3 and 4. 4 times comparison is there. Again here 3 is comparing with others. 1, 2 and 3. Only 3 comparisons are there. And here 8 is comparing with 12 and 5. So only 2 comparison is there. And in last 12 is comparing with 8. Only 1 comparison is there. So this we can consider as the outer block and this is the inner block. Inner block I will just try to give some other color. Say okay, blue color. Now we will try to implement this sorting. Before implementing one more thing, like we have to replace the values or we have to swap, interchange the values. So how to interchange the values? For that explanation, I'm just taking 2 numbers over here. So imagine first is memory space A and second memory space is B. First value is 10 and here the 20 value is there. I need to replace A and B value. So if you are trying to assign A equal to B, your A will be lost over there. So you can't save that 10 to here. So we need, of course, we need a third memory space. I'll just name as temporary T. First, either A or B value we have to save inside the T. So what we will write? T equal to A we can write. So that means T value will be now 10. It's copying over there. Now we can remove this 10 value. So I will write A equal to B. So always left hand assignment. Right to left value will be assigned. So B value is assigning to A. B value is assigning to A means like this will be 20 now. Now both are 20 actually. Now the third step will be B equal to T. T value is 10. So here it will be 10. Now the values are changed. Instead of 10 20, now it's 20 10. So this will be our idea to write the program. Now we will write the code. Here you can see like already I'm reading an array over here and printing that array and give a message after sorting. The reading and printing that we already discussed in previous classes. So I had to just write the steps for sorting only. So here I'll just write the steps for sorting. We are trying to write the selection sort. So I'll just put a 2 marks over there just to identify where we are writing the program. Here the selection sort start and ends. In between we have to write the program. See the outer loop. It's working 1 to 4. 4 times it should work. For that I am using a for loop which will control with I. I is less than n. I plus plus. But if I am writing I is less than n is 5 and this will work 0 to 4. 0 to 4 means 5 times it should work. It will work. But I don't need to run that much time. So I will just give n minus 1. So now it will work from 0 to 3. 0, 1, 2 and 3. Of course we are getting 4 times. Now inside loop it's working from 4 to 1. Okay. And we are starting the comparison. First from the 0 itself. Second comparison is starting from the 1. Like that it's going. So if you're writing the second loop for int j equal to always starting from the next number of I. So I plus 1. J is less than n j plus plus. Till the last number we have to do the comparison. So this time depend on the I value. the number of execution will be less. First time it will be 1 to 4. That means 4 times itself. Second time it will be 2 to, because 1 I is 1, 1 to 1 plus 1, 2. So 2 to 4. So 2, 3, 4. Only 3 times it will work over there. And again, next time, here it is 3 to 4. 3 and 4, 2 times. Then 4 to 4, 1 time. Like that it will automatically decrement the execution. Now we need the variables called small, position, and for interchanging or swapping case we need a temporary variable. So those values I will declare over here. We need a small variable, we need a position variable, and we need a temporary variable. So all these things are declaring over there. First, we had to save the smallest value inside SML. In beginning, we are considering ith value or 0th value will be the smallest. So I can take AR of I, and the position will be I itself. Now inside the inner loop, we have to do the comparison. We have to find out a number smaller than SML is there or not inside the loop. So we'll write if SML is greater than AR of J, because it's an inner loop. So if we can find out a smallest number other than the SML, then what we have to do? We have to replace that SML with that number, and the position should mark with that position. Here J is the position, so I'm marking that one. And after completing this all the comparisons, before starting the next iteration, we have to interchange the values. So interchanging values already given over here like this. So after this loop, inside the inner loop itself, I'm trying to do the interchanging. First we are saving the first value, say AR of I to the temporary memory space. Now I can change that AR of I with AR of pos value, because it contains that positional value. Then we need to save the AR of pos value with temporary. So here it actually it's replacing. So swapping procedure is ends. Now we will check with the same numbers and we'll find out whether it is working properly or not. Saving the program, running the program, giving the same limit over there 5, and giving the same numbers 5, 3, 8, 12, and 2. See, this is sorted over there. And if you want to sort reverse, just need to change this comparison only. Need to change the comparison. Instead of greater than, you can just put less than. And of course, if you want to change the smallest into large, the name of the variable, if you want to change, you can do that. Anyway, I'll just check it again. Giving the same numbers, 5 limit, 5, 3, 8, 12, and 2. Now this is in descending order. So to change the ascending or descending order, you have to just change the symbol only. Now, if you want to cross check all these values, then after this swapping concept, you can put this printing statement over there and just run the program. Giving the same number 5, 3, 8, 12, and 2. Now see, first is changing into 2, 3, 8, 12, and 5, right? Second, 2, 3, 8, 12, and 5. 2, 3, 5, 12, and 8. Finally, 2, 3, 5, 8, and 12. So you can see that working over there. The same thing you are getting over there. Anyway, this is for checking purpose only, so we can avoid if you don't want to print those stuffs. So this is the selection sort part. Only this much we have to write for the selection. These are the previous reading and printing. In between, we return the selection sort part. I think this is clear for you. Now we will switch into the bubble sort concept. With the same numbers, we will try the bubble sort also. First, I will explain how this bubble sort is working. So here we taken the same numbers over there, only 5 numbers, and 3 different numbers are given over there. In bubble sort, we have to compare the adjacent numbers. Okay, in bubble sort also we will discuss the ascending first. So if the first we will start from the first 2 number comparison, and if these from these 2 numbers, first number is greater, then we have to replace that numbers, or we have to swap the numbers. So here first comparison 5 and 3. 3 is smaller. So that time itself I have to change 3 and 5. So I'm copying this number. So it should be replaced like this. Now the next thing, so here you have to sort this 5 and 8. And we can say, so compare this 5 and 8. We don't need to interchange because 5 is lesser itself. So we don't need to do the interchange. So I'm copying this numbers again. Now we should compare with the 8 and 12. Here we need a interchanging because 8 is lesser. So here the 12 will come, here the 8 will come. Now the next thing we have to compare 8 and 2. First we'll go through the bubble sort working. So here I taken the same numbers again 5, 3, 8, 12, 2. 5 numbers it's taking over there. In bubble sort we have to compare the adjacent numbers, and if you are taking the ascending order, if your second number is smallest, then you have to replace. If your second number is smallest, then you have to replace. So if you are taking 5 and 3, that time itself you have to change this 3 and 5 itself. So that I will write in a next block. Here it should change with 3 and 5. Now the next comparison with the next two numbers we have to try. But here if you are taking the second number is not smallest, so we don't need to make any interchange. Now we will compare with 8 and 12. Here also second number is large, so we don't need to do any changes over there. Now the next comparison will be 2 and 12. Here second number is small, so you have to replace this 12 and 2. So it will be like this. Again there is no other number over there, so you don't need to do the comparison over there. And you can find out the last number will be the largest among all. Or we can simply say we don't need to sort the last element. So here this is worked 4 times and we are getting this number. I'll just give a border for this. Again, we should start from the beginning itself. 3 and 5. Here 5 is larger, so no need to change. Second number is largest. Now the next one, 5 and 8. Second number is large, so don't need to make any changes over there. Now we have to compare with 8 and 2. Here 2 is smaller. Of course, we need to make the changes. So 8 and 2 should be replaced. Here it should be 2 and this one should be 8. And we don't need to compare with the 12 because it's already avoided from the sorting session. It's already sorted. Now we can say this number also is sorted. So last two portions we can ignore. Now we have to do the comparison from here itself. So I'm just moving that portion to here, somewhere here. So this time we have only 3 comparisons and last two numbers are sorted order. Repeat the step. 3 and 5. Again compare. 5 is large, so no need to make any changes. Repeat the same thing with 5 and 2. 2 is smallest, of course we need to do the interchange. So here 2 will come and this is 5. Now we need to compare with the 8, so that comparison is over. So only 2 times comparison we needed over here. Now repeat the same thing again. Before that, this 5 is already sorted. Now repeat the same thing. Compare 2, 3 and 2. Compare 3 and 2. 2 is smallest, so we have to do the, so we have to interchange. So 2 should come here and 3 should be here. No need to compare with the 5 because it's already in sorted session. And we can say this is also in sorted order now. So the comparison is finished or sorting is finished over there. We don't have any other number to do the comparison. So after this much session, the program is ending. So here only one time comparison. So this is the first session, second session and third session, and this is the fourth session. So outer loop will work 4 times. So outer loop is working 1, 2, 3 and 4. And see the inner loop workings. 1 comparison, 2, 3 and 4. So first time 4 comparisons are there for inner loop. Next time 3 comparisons only. Then 2 comparisons only. Then 1 comparison. Finished. It's already sorted. Now we will try to implement this sorting inside our program. So here, this sorting portion I'm just replacing. Now this is like bubble sort. First I'll just write the outer loop. That should work 4 times. For int I equal to 0, I is less than n minus 1, I plus plus. Now I can write the inner loop, and this is always starting from the 0th value itself. So here I have to give the j or inner loop value always starting from 0, n minus 1 minus I. So first time it will be like n minus 1. Imagine n is 5. So 5 minus 1, 4. So 0 to 4 it will work. 0 to less than 4 it will work. 0 to less than 4 means like 0, 1, 2 and 3. First time it will work 4 times. Then 4 minus 1. I value will be next value will be 1. So this will automatically decrement. Now how to compare the adjacent numbers? AR of j is the first number, should compare with the next number. So first number AR of j is greater than AR of j plus 1. Then we have to do the interchanging. We need a temporary variable over there for the interchanging. So temp value will be assigned with jth value. Now I can give the jth value as the next value. Now this next value should be replaced with the temporary value. Our sorting is finished. Now we can run and check. So only this much we need to do for the bubble sorting. We'll give the same numbers over there. 5 numbers totally. First number is 5, 3, 8, 12 and 2. See, this is already sorted. And if you want to sort descending order, just reverse this comparison and run it again. 5 numbers, 5, 3, 8, 12 and 2. Now this is descendingly sorted. I think you got the idea how it's working. So we are winding up today's class. Please subscribe, like and share the channel. Thank you for watching. Have a nice day.